Good morning, this is Kasturi De. Today again I'll discuss the question answers of the force and pressure chapter according to ICSE syllabus class 8. So today I'm starting with the question number 38. Give reasons for the following. Okay. So why does a balloon collapses when air is removed from it? See, when air is removed from a balloon, the pressure inside the balloon, which is due to the air in it, becomes less, okay, than the atmospheric pressure outside. So therefore, the balloon collapses. Pressure is outside, the atmospheric pressure is more, so that exerts more pressure on the balloon, because there is almost no pressure inside the balloon. Therefore, it collapses. Now, water does not run out of a dropper unless its rubber bulb is pressed. Why it is so? Because the atmospheric pressure acting from outside the dropper balances the pressure which is exerted by water, and water does not come out of the dropper. Okay, so inside the dropper there is water, and outside the dropper, that is atmosphere, that is air. So both the things, that is outside the dropper, that is air is exerting a pressure, and also the water which is inside the dropper, that also exerting a pressure. So these two pressure becomes equal, and therefore the water does not come out of the dropper. But on pressing the dropper, what happens? Inside the tube, inside the dropper, the water becomes more. Okay, inside the pressure of the water becomes more than outside the water pressure, outside atmospheric pressure of water, and therefore water runs out. Okay, then two holes are made in the sealed oil tin to take out oil from it. What happens? So that air presses the oil at one hole. From one hole, the air is going inside the tin, which is exerting a pressure on the oil, and the oil is coming out from the second hole. Now we are coming to some numericals. Find the moment of force of 20 Newton about an axis of rotation at a distance of 0.5 meters from the force. See, moment of force, we know that moment of force is equal to the force, the magnitude of the force, into its perpendicular distance from the force. Okay, so force, we know here it's given as 20 Newton, and perpendicular distance given as 0.5 meters. So moment of force will be 20 into 0.5, that will be equal to 10 Newton meters. Next, the moment of force of 25 Newton about a point is 2.5 Newton meter. Find the perpendicular distance of the force from that point. Again, force given is 25 Newton, and moment of force given is 2.5 Newton meter. So moment of force will be equal to force into perpendicular distance of the force. So that will give the distance as 10 centimeters. 1 by 10 meters or 10 centimeters. Next is a spanner of length 10 centimeter is used to unscrew a nut by applying a minimum force of 5.0 Newton. Calculate the moment of force required. See, distance it's given as 10 centimeter, or you can say 1 by 10 meters. Then force given is 5 Newton. So moment of force will be 0.5 Newton meters. Then a wheel of diameter 2 meters can be rotated about an axis passing through its center by a moment of force equal to 2.0 Newton meter. What minimum force must be applied on its rim? Again, distance given is 2 meters, moment of force is 2.0 Newton meters. So moment of force will be equal to force into distance of the perpendicular distance. Therefore, this moment of force, which is given 2, and distance is given 2 meters again. So therefore it will be, force will be 2 by 2, that is 1 Newton. Again, A normal force of 200 Newton acts on an area of 0.02 meter square. Find the pressure in pascals. Pressure will be force by area. So force given is 200 Newtons and area it is given 0.02 meter square. So this pressure will be 10,000 pascals. Find the thrust are required to exert a pressure of 50,000 pascals on an area of 0.05 meters square. So we know that pressure is equal to force by area or thrust by area. The pressure is given as 50,000 pascals and the area is 0.05 meter square. So therefore this thrust will be equal to 2500 Newton. Then find the area of the body which experiences a pressure of 50,000 pascals by a thrust of 100 newtons. So again pressure is equal to thrust by area. So therefore area will be equal to thrust by pressure. So 100 by 50,000. Okay, that gives us to 2.2 into 10 to the power minus 3 meter square. Next we come to calculate the pressure of in pascals exerted by a force of 300 Newton acting normally on an area of 30 centimeters square. So force given is 300 Newton and this area will be equal to 30 centimeters square, or you can say 30 by 100 into 100 meter square. So that will be equal to 10 to the power 5 pascals. Again, how much thrust will be required to exert a pressure of 20,000 pascals on an area of 1 centimeter square. Again same thing, pressure will equal to thrust by area, pressure given, area given, and we need to change the centimeter square into meter square in case of area. Okay, and therefore that will give us 2 Newton. The base of the container measures 15 centimeters into 20 centimeters. It is placed on a tabletop. If the weight of the container is 60 Newton, what is the pressure exerted by the container on the tabletop? Again, see, area is given in centimeter square. We need to convert it into meter square. And the force is given as 60 newtons, and therefore the pressure will be equal to 2000 Newton per meter square or 2000 pascals. Then calculate the pressure exerted on a surface of 0.5 meter square by a thrust of 100 kgf. Okay, so pressure equal to force by area. So 100 by 0.5. Therefore, that gives us to 200 kgf per meter square. A body weighing 60 kgf stands on a platform of dimensions of 2.5 centimeters, 0.5 centimeters. What pressure in Pascal does it exert? So force will be equal to 60,000 kgf, and that becomes to 600 newtons. And dimension is given as 2.5 centimeter into 0.5. So area will be equal to 1.25 by 100 by into 100 meter square. Okay. So then this pressure will be equal to 4.8 into 10 to the power 6 pascals. Okay. Next we come to a brick of weight 2 kgf and dimensions 20 into 10 into 5 centimeter placed in a 3 different positions on the ground. Find the pressure exerted by the brick in each case. So in first case, the area is the cross sectional area is 20 into 10. Okay, so 200 centimeter square. So therefore force is given as 2 kgf, pressure will be 0.01 kgf per centimeter square. In the second case, the area is given as 5 centimeter into 10 centimeter. So that gives us to 50 centimeter square. Force is same, 2 kgf. So pressure will be 0.04 kgf per centimeter square. In the third case, the area is 20 into 5 centimeter. So force is 2 kgf, and therefore the pressure will be 0.02 kgf per centimeter square. Then question number 14, a force of 16 Newton acts on an area of 50 centimeter square. What is the magnitude of the pressure in Pascal? Again, area is given, force is given, so pressure will be equal to 3200 pascals. Then a force F acts on an area of 600 centimeters square and produces a pressure of 12,500 pascals. Calculate the magnitude of force. So force area is given 600 centimeters square, we need to convert it into meters square, and pressure is given in Pascals 1000, I mean 12,500. So pressure equal to force by area, or force is equal to pressure into area, that gives us to 750 newtons. Then a force of 300 Newton while acting on an area A produces a pressure on 1500 pascals. Calculate the magnitude of A in centimeters square. Force is given as 300 pascal is pressure is given in 1500 pascals. So pressure is equal to force by area, or area is equal to force by pressure. That gives to 200 centimeters square. I mean 2000 centimeters square. Then what is the area of cross section of a body in meter square when it exerts a force of 50 Newton and produces a pressure of 20,000 pascals? So force is given as 50 Newton and pressure is given as 2000 pascals. So pressure is equal to force by area, or area is equal to force by pressure, and that gives us to 0.025 meters square. Then a force of 10 Newton acts on a body such that the moment of force is 20 in Newton meter. Calculate the perpendicular distance between the force and the turning point. So force is given as 10 Newton, moment of force is 20 Newton meter. So moment of force is equal to force into perpendicular distance. So distance will be equal to 2 meters. Okay. Then a force of 20 Newton acts on an area of 50 centimeters square. Calculate the value of the pressure in pascals. So force is given as 20 Newton and area is 50 centimeters square. We need to convert it into meter square, that is 1 by 200 meters square. So pressure is equal to force by area, that gives us to 4000 pascals. So this is the end of this chapter, force and pressure. Okay. Next chapter will be on energy. I'll make the video on that. So please go through this. If you have any doubt, please let me know. Please do write in the comment box, and I hope that you are liking the videos. Press the like button if you are liking it, and share with your friends so that they can also be benefited from these videos. And if you are a new viewer to my channel, please do subscribe to get the notification of my next video. Or if you have not subscribed yet, then also please do subscribe. Okay. And if you want your doubt clearing session, please do write in the comment box so that I can make some live session for you so that you can clear your doubts. Okay. So thank you.